Ethers, epoxides, and sulfides. In this chapter, we will talk about the structure, nomenclature, physical, and chemical properties of these three compounds, ethers, epoxides, and sulfides. To begin with, let's talk about ethers. What are ethers? Ether is an organic compound where the oxygen is connected to two carbons. Here is a simple representation of an ether where you can see that this R group is going to represent the alkyl group. Remember, this R group can also be switched to an aromatic ring structure, and in which case it's going to be an aryl ether. The structure of ether is similar to that of water and alcohol with an increased carbon-oxygen-carbon bond angle. Also, the two sp3 hybridized orbitals of oxygen is going to form two sigma bonds with the two carbons, and the remaining two sp3 hybridized orbitals of oxygen is going to exist as two lone pairs of electrons on oxygen. Classification of ethers. Ethers can be classified as symmetrical or unsymmetrical ethers, depending upon the alkyl groups or the aryl groups that are present on it. If the two alkyl groups or aryl groups are exactly the one and the same, then it's going to be called as a symmetrical ether. And if they are going to be different, then it's going to be called as the unsymmetrical ether. Okay, so this is an example for unsymmetrical ether, whereas this is a representation for symmetrical ether. Now let's do some examples here. Let's go on to the very first example. Is that a symmetrical ether or an unsymmetrical ether? Okay, so you have two ethyl groups, one on each side, and therefore this is definitely a symmetrical ether. So this is called as diethyl ether. And here, this is going to be an unsymmetrical ether because you have two different groups on it. So you have a methyl group here, and you have an aryl group here, right? And then the next one is tetrahydrofuran. This is a symmetrical ether. This is also a symmetrical ether, where you can see that there is some sort of symmetry in this molecule. So this is a symmetrical ether. This is also an example for symmetrical ether. Common names of ether. For the common names, we are going to list the substituents in alphabetical order. Let's take our very first example. Now let's first identify whether it's a symmetrical ether or unsymmetrical ether. Yes, of course, it is an unsymmetrical ether because there are two different alkyl groups on it. Okay, let's identify the two alkyl groups that we have here. So this is an ethyl group and this is a methyl group. And if you want to name this ether, then you have to list the substituents, which is the ethyl group and the methyl group, in alphabetical order. And accordingly, the name for this is going to be ethyl methyl ether. That's the common name for this molecule. Now let's go on to the next example that we have here. So in this example, we can see that the two alkyl groups are one and the same, in which case we are going to use the prefix di. And what is this alkyl group that we have here? This is an ethyl group, right? So the common name for this is going to be diethyl ether. Let's go on to the next one. Now let's identify the two different alkyl groups that we have here. Okay, this is an example for an unsymmetrical ether where you can see that this is one of your alkyl groups and this is our other alkyl group. Now what is this group right here? This group is tertiary butyl group, right? So tertiary butyl group, whereas the one on the left is going to be an isobutyl group. And if you want to list this in alphabetical order, it's going to be tertiary butyl isobutyl ether. Okay, remember when you're arranging the substituents in alphabetical order, the tertiary, you have to avoid counting this towards your alphabetical order. The tertiary should be avoided. So it's going to start with butyl and it's going to start with I. So between B and I, which one is going to come first? The B is going to come first. So you have to put that as a first substituent. Now let's go on to the next one. So is it a symmetrical ether or an unsymmetrical ether? Okay, again, it's an unsymmetrical ether. We have a secondary butyl group and we also have an isopropyl group, right? So altogether, again, the SEC in the secondary butyl should be avoided when arranging the substituents in alphabetical order, right? So it should be secondary butyl followed by isopropyl ether. So that would be the proper name for this molecule. Now let's go on to the next one. Okay, again, this is also another example for an unsymmetrical ether where you can, where you can see that this is one of your substituent, and the other substituent is this group right here, and this is an isopentyl group. This is an isopentyl group, and this is a cyclohexyl group. Now, how are we going to arrange this one in alphabetical order? Obviously, the C is going to come first, and then comes I, right? So you have to put the cyclohexyl group in the front, followed by isopentyl group, followed by the parent name ether. IUPAC names of ethers. For the IUPAC name, we are going to first find out which alkyl group has got the longest chain. Okay, so the longest chain is going to be our parent name. So the longest carbon-carbon chain is our parent name. And the next thing we are going to do here is, leaving the parent chain, there should be an alkoxy group, right? And this alkoxy group is primarily going to act as a substituent. And if there are more than one substituent, then we have to list them in alphabetical order. Let's do this with an example. Here is our first ether molecule. And we can see from here, there are two alkyl groups. There is a methyl group here, and there is a butyl group here. Between these two groups, which one has got the longest chain? Obviously the butyl group, and therefore that should be the parent name. And the parent name here should be butane. And leaving the butane, we can see that there is an alkoxy group. This should be considered as an alkoxy group. And to be more specific, this is a methoxy group, and this methoxy group is actually present on the second carbon of the butane molecule, right? So this is going to be called as 2-methoxybutane. Now let's go on to the next example. Okay, we'll do exactly the same thing for the next example. So here is our ether molecule. Let's find the two alkyl groups. We have an ethyl group here, and we also have an alkyl group which has greater number of carbons than the ethyl group, right? So obviously this is going to be our parent name, but this parent name is actually, or this longest carbon-carbon chain is branched, right? So in which case we have to adopt all the rules that we have learned in naming the alkanes. So your first carbon is going to start from here. Our first carbon is going to start from here, and you're going to go in the direction leading to the higher number of carbons. So that would be 5 carbons, so which means the parent name here should be pentane, and on pentane is present a methyl group on the third position, right? So it's going to be 3-methylpentane, and leaving the 3-methylpentane, okay, the remaining group is an ethoxy group, and this ethoxy group is actually present on the first carbon of 3-methylpentane. So the whole name for it, this is going to be 1-ethoxy 3-methylpentane. Now let's go on to the next example. Let's find the two alkyl groups here. So this is one of the alkyl group, and this is the other alkyl group. Okay, so between these two, which one has got higher number of carbons? Obviously the one on the left, right? So it's going to be, let's number the carbons. So 1, 2, 3, 4, 5. This is again pentane. Okay, on pentane is present 2 methyl groups, one at position 2 and the other one at position 3. So this is going to be 2,3 dimethylpentane. Okay, and leaving the 2,3 dimethylpentane, we have an butoxy substituent. Here is a butoxy substituent, and this butoxy substituent is present on position 1 of 3-dimethylpentane. So it's going to be 1-butoxy 2, 3 dimethylpentane, and do not forget to put the hyphen between the alphabet and the number. Okay, now let's go on to the last example that we have here on the slide. So here is a situation where there is 2 ether substituents, right? So let's identify the 2 ether substituents. So basically this is going to be one of your ether substituent and this is going to be the other ether substituent. Now let's do exactly the same thing here again. Let's take this ether and find out which one has got the longest chain here. So obviously this part right here is going to have the longest chain. And what is this part? This is actually a butyl substituent, right? Basically it is derived from butane. Okay, so this is butane. And what is this group on the left? This is an isopropyl group. And remember, if this is going to be a parent chain, this should be our alkoxy group. And this is going to be isopropoxy. So on the whole, we have this is isopropoxy butane. But this isopropoxy group is repeated on the other side of the butane molecule, where you can see that this is your another isopropoxy group. Now we have to make sure that we have to give the numbers for these substituents. So for that, we are going to number these carbons starting from here 1, 2, 3, 4, or you can also go in the other direction because it's a symmetrical compound, right? And now since you have 2 isopropoxy group, it has to be having the prefix di. So it's going to be diisopropoxy butane. But where are these 2 isopropoxy group present on butane? They are present on the first carbon and the 4th carbon, and therefore this is on the whole called as 1,4 diisopropoxy butane. Cyclic ethers. Cyclic ethers are given special names. The presence of an oxygen in a saturated ring structure is indicated by the prefix ox. And depending upon the ring size, they can have different suffixes. Now let's take a look into these different cyclic ethers and give a name for these. Okay, so this is when the ether is actually a 3-membered ether or 3-membered cyclic structure, then this is going to be called as oxyrane. This is oxyrane. When it's 4-membered ring structure, then it's going to be oxetane. And when there are 5 atoms in the ring structure, then it's going to be called as oxolane. Oxolane. And when it's going to be 6-membered, it's called as oxane. And take a look into this. Here you have 2 ether groups, and therefore this is called as dioxane. And the 2 oxygens are present in 1 and 4 positions. So this is 1, 2, 3, 4. Therefore this is going to be called as 1,4 dioxane. Let's do some exercises on the IUPAC and common names of the ethers. Here is the first example. To begin with, for the common name, we are going to find the alkyl groups and list them in alphabetical order, adding a suffix of ether, right? So for this compound right here, we have an ethyl substituent and we have a tertiary butyl substituent. And between these two, which one is going to come first? Obviously, the tertiary butyl substituent is going to come first because B comes first and then comes E, right? So the right name for this is going to be tertiary butyl ethyl ether. And remember, we have to avoid this third from being counted towards in the alphabetical order, right? So on the whole, it's going to be tertiary butyl ethyl ether. So this is the common name, right? And for the IUPAC name, we are going to find the longest carbon-carbon chain. So let's take a look into here. So we have an ethyl group which has 2 carbons, but here this is kind of considered as a propyl group, right? Or propane molecule, right? Which has got 3 carbons. So obviously this is going to be our parent chain. So where you can see that there is a methyl group that is attached to the propyl group, and therefore this is going to be called as 2-methylpropane. 2-methylpropane. And why this is 2-methylpropane? Again, we have to number the substituents or number the carbons. So 1, 2, 3. On the second carbon of propane molecule, you have a methyl group. So it's going to be called as 2-methylpropane. And we have an ethoxy group. Right? This is our ethoxy group. And where is this ethoxy group present on the propane molecule? It's also present on the second carbon. Therefore, this should be written as 2-ethoxy 2-methylpropane. Let's go on to the next example. Here is an example for a symmetrical ether, and you can see that because there are exactly the same alkyl groups on it. What is this alkyl group? This is a cyclohexyl group. And because there are 2 cyclohexyl groups in here, the common name for this is going to be very simple. We're going to write this one as dicyclohexyl ether. Okay, and for the IUPAC name, so this is our common name, and for the IUPAC name, remember we have to call one of these groups as oxy, right? Followed by the parent name. The parent name here is going to be cyclohexane. So you're going to treat one of these alkyl groups as a parent name, and the other alkyl group is going to act as an alkoxy. And this is going to be cyclohexyl oxy substituent. Cyclohexyl oxy group that is present on the cyclohexane. Okay, now let's go on to the next example. So this is an ether where you can see that there is unsaturation. There is a double bond right there. So this is to be treated as your alkyl group, whereas this one is your alkenyl group. So how are we going to name this compound? So for the common name, let's find out. So here you have a methyl group, and this one is an ethenyl group. Or you can also call this as vinyl. Either way, it should be okay. Okay. So the common name should be written as ethenyl methyl ether following the alphabetical order. But if you replace the ethenyl group with vinyl, then it should be the methyl group which is going to come first, right? Because M comes first and then V. Methyl vinyl ether. Coming to the IUPAC name. Okay. So between these two substituents, which one has got higher number of carbons? So obviously the ethenyl group, right? So this has to be called as ethene, which is going to be our parent name. And then the remaining substituent is going to be your alkoxy group. More specifically, it is the methoxy group. So methoxyethane, that would be the IUPAC name for this molecule.